Have A of t 10,000 e to 0.025t plus 15,000 e to negative 0.04t, and this is 42 on 291. After how many years will the combined value of the two properties be a minimum, and what will the combined minimum be? Okay, so as we know, we have to find f prime of t. So I have 10,000 times this. So I multiply this by 10,000 and I have 250t e to 0.025t. Now let's see what this is. Let me write it so I don't make an error. Negative 0.04 times e to negative 0.04t. Am I correct here? I have 4 zeros, and when I moved, yes. Good. That one is okay. Now, what do I get? Okay. I was doing some statistics with a student, and she dropped. Not the class, but she just disappeared from from Zoom. So I couldn't finish the problem with her. I was hoping she would come back, but she didn't. So something must have happened at her end. Times 0.04. I need this number, it's 600. Okay. So this is 250 e to 0.025t minus 600 e to negative 0.04t. Good, so when we, oh, I see the difficulty. Okay, it's clear now. Okay, so when I set this equal to 0, I have 250 e to 0.025t equals 600. So the problem was in analyzing, simplifying this. Got it. So I will divide both sides by either one, it doesn't matter. So if I divide by this, then I have e 0.025t over e negative 0.04t. And here I have 600 over 250. So I divided both sides by this, and I divided both sides by 250. See, when you cross multiply, this times this is here, this times this is here. Thank you for asking about this problem, by the way. I think Jelen asked about it, but now I realize what the problem was. It was just solving such an equation. Got it. Good, so I copy the base and subtract the exponents. So from the top, I subtract the denominator, but I have to change the sign, right? So I have 0.025t minus negative 0.04, so plus 0.04t equals whatever this is, I don't care. Okay, so then e to 0.065t equals 60 over 25. We apply natural log to both sides. So this is all algebra. This has nothing to do with calculus. So from this point on, this is just algebra. Okay, so let's continue. I have 0.065t equals natural log 60 over 25, or t equals this over that. Natural log 60 over 25, 0.065. So let's see, approximately t equals. Let me just make sure that I have here for 65. Yeah, it appears that everything is correct. Okay, so I'm going to share my screen, and then I have natural log 60 over 25 and divided by 0.065, and appears to be 13.5. 13.5, and how many years? And please understand that this is not enough. Okay? Yes, any questions? Ari, go ahead.
I was asking, can you like slow down because you're going way too fast?
Say that again.
Can you like slow down and kind of explain it because you're going too fast?
Which part is not clear?
No, I'm just, it's not that it's not clear, it's just that you're going too fast, like to like write everything down.
It's possible, but this is again just algebra, right? It's just prior to this class. So where are you right now? Which part?
Never mind.
Are you caught up or not yet?
That's fine.
No, I'll wait. I'm not sure whether is this good enough or
Yes, fine.
okay. Did you write all this? Okay, so this is a prime of t. So I have 0 here. And here is the function, a prime of t. So here I have to plug in 0 and let's say 100. When I plug in 0, these two are 1. 250 minus 600, this will be negative. Now let's see what happens when I plug in 10. That part is more difficult. So I'm going to do this part with a graphing calculator. So I have 250 times e to 0.025 times, I said 100, doesn't matter really, anything greater than 13. So minus 600 times e to negative 0.04 times 100. And close, and I hope, before I click, I hope that this is positive. Yeah, that's all I needed. I only needed to see if it's positive. So now this is guaranteed to be a relative min. And it says, what is the relative min? So then I have to go back to the function and plug in 13.5. So this will be a of 13.5. And in part B, it says a graph for 0 to 20. I'm not asking you to graph at this point, something like that. If you remember, I said do not graph in 3.1 and 3.2. So just part A. We can graph it, but only with the graphing calculator. I mean, you saw how long it took us to put that, to go through all the steps. So we can graph it with a graphing calculator, but I'm not really interested in calculator work because it requires a lot of steps. I have to find the second derivative, etc., etc. Do you need me to continue here, just plug it in, or can you plug it in? Any questions on this? Anyone? Any questions? Anyone? Please say something. So can I move on, or are we ready to move on?
Yes.
We're better with that one.
Okay. Any questions? Anything else you worked on that you, from MyLab Math, that you need help with? Anything? Anything? Anything else?
Professor Lee.
Yes, I'm here. Anything else? Anything? Yes?
Can we check number 36, please?
36?
Yes, please.
From what?
From the homework.
Okay. So is that okay then if I don't post these solutions because we have them here? If we're doing the second problem, is that okay with you? Okay, so this is 0. F double prime of -1 greater than 0. f of -1 equals -5, f of 7 equals 0, f double prime of 7. Did you look at the problems we did in class? Did you redo the problems we did in class?
I did, but I was late because Zoom was not opening, so that's why I
Okay.
missed that part.
But I have the videos, right? I have the lecture notes posted. Did you watch that? It's very important to redo that. It's very important because it's so much material to cover, so much. So we have x, we have f prime of x, we have f of x, and we have the second derivative. Okay, again, this is gibberish for me. If I don't put it organized in a table, it doesn't mean anything. I can't follow this. I cannot even explain what it is. Okay, so I will start with f of -1, which is -5. F of -1 equals -5. This is done. F of 7 equals 10. This is done. F of 3 equals 2. This is done. I have f prime of -1 is 0, which means this is a critical number. This is done. I have f prime of 7 is 0. This is done. It's another critical number. I have, so now the remainder are all about the second derivative. Okay, the second derivative of -1 is positive. So this is done. Second derivative at 7 is negative. This is done. And I also have the second derivative at 3 is 0, which appears to be an inflection point. Good. So now I know that the function, because it holds water according to the second derivative, this point, -1, -5, must be a relative minimum. This must be because the derivative changes sign, and it's 0 at 3. This must be an inflection point. And here, the function doesn't hold water, which means that this point 7, 10 is a relative max. So all I have to do now is give my version of the graph. Everyone can have a totally different version of the graph. So at -1, I have -5. And that's a relative minimum. At 3, 2, the function has an inflection point. And at 7, 10, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that is a relative max. So here's my graph, inflection point, and relative max. It holds water. In other words, it's concave upward. It has an inflection point at 3, 2. So this is the relative min. This is the IP, and this is the relative max. Any questions on this?
Yeah.
Yes?
For our graph, do we have to label them?
No.
Okay, all right. Because I got the graph right.
No. No, you don't. I just wanted to specify them from the table.
Thank you.
My pleasure. Other questions? Anything else you tried? No one is asking anything about my math lab, my lab math, which means, is it done? Is it not done? Do you have questions? You don't have questions? So no one wants to say anything about it? I did not check today. I did check before the weekend was over, but I did not check today, so I don't know where you are. Okay, so we looked at one graph last time. Let's look at another graph this time. And I think we did number 43. So let's look at something like f of x equals x squared e to 5x. This book loves natural log and e to the x. And then let's look at a word problem so we can continue. So this is on page 305. We are still in 3.3. Hopefully we make progress today. Okay, so the question here is asking us just everything. Indicate where the function is increasing, decreasing, relative max, asymptotes, if any, concave up, concave down, and where any intercepts occur. It doesn't say to graph the function for this particular problem. Okay, it's just asking us to basically fill up the table. Good. So we always start with the domain. Can anyone give us the domain of this function? What do you think?
Negative infinity, positive infinity.
Brilliant. Thank you very much. Of course, e to the x is a friendly function, x squared. This is a product, no problems. Indeed, negative infinity to infinity. Perfect. So no vertical asymptotes for sure. Good. Excellent. So 0 has to be in the table. And just please tell me what is the function value when x is 0.
Zero.
Yes, of course. Very good. We have to determine these limits. So notice that I always start with the function. First is the domain, and then I exhaust the function, x and y intercepts, and the limits. Okay? When I set this equal to 0, only x can be 0. This will never be 0, so that's the only option. But I also have to finish by finding the limits. Once I finished with the x and y intercepts and the limits, then I move on to the first derivative, and then I move on to the second derivative. Okay. So, limit as x approaches infinity from x squared e to 5x, and limit as x approaches negative infinity from x squared e to 5x. So don't look at this one just now, just look at that and tell me the answer. When x approaches infinity, where does x squared go? Anyone?
Positive infinity.
Sure. And what about e to infinity? Where will e to infinity go?
Positive infinity.
Good. Excellent. Good. So now let's talk about this one. Because this one is a little bit different. This piece approaches infinity. But this piece is e to negative infinity, which approaches 0. And we cannot conclude. So in this class, we did not discuss this 0 times infinity as an indeterminate case. I do talk about all 7 indeterminate cases with my Calculus 191 class. But in this class, we only discussed 0 over 0 and infinity over infinity. We did not discuss something like this. You could say, but 0 times anything is 0. Not exactly. 0 times infinity may or may not be 0. So it's not guaranteed. So what I